Hello everybody and welcome back to our videos on deep learning. Today we're going to be talking about data sets and how PyTorch deals with them. So for any kind of PyTorch programming, when it comes to projects, you'll obviously have some data that you'll have to load and then you can use PyTorch to actually build your neural network and process that data in some way. So how we're dealing with data sets is an important part of any project, which is something we're going to be looking at today. So we have another notebook on Google Colab here. We're going to be demonstrating a few examples using this. Obviously the notebook again will be publicly available and will be linked for you to easily access. All right, so again, as usual, let's start with loading what we need. Here we're going to be loading Torch and Torch Vision. Torch Vision is a library built for PyTorch, which specifically helps us deal with vision data. A lot of data sets are already built in there. We'll take a look at some of those shortly. And a lot of tools that will help us process this data very easily. There is also Torch Text, which helps us deal with text, and there is Torch Audio, which will help you deal with audio data. But obviously by default here we're going to only be working with images as the most common, arguably, and representative of the sort of projects that you might be dealing with. So in order to be working with data sets, I've created a simple sample data set here to use. Obviously PyTorch has a lot of data sets built into it, Torch Vision especially, which you can just use out of the box. But here we're going to try to have a bit more challenging case of working with our own data set. So the data set I have created, I have called ACBins, which is made up of images from two of my favorite Star Wars characters, namely Admiral Akbar and Jar Jar Binks, hence ACBinks. So we have a number of images. We have 60 images of each character in our training set and 30 images in our test set. It's a very small toy data set we're going to be using for our examples here. Now obviously in the first instance we need to download this data set and unzip it. So let's just do that very quickly here using wget. This is available on my GitHub page. It's going to download it, it's going to unpack this and remove the zip file. Yes, and that is done. It's a small data set, so it shouldn't take very long. Now we'll be looking at images from this data set later, but for now we know that if we look at here, we have ACBins in our file, a test directory and a train directory, which is normally how we structure the data sets to work with easily. So now we will need to transform the data. No matter what kind of data we were working with, it's very rare that you'll use the data in its raw format. There'll have to be some transformation that is applied to your data to get them ready to be passed through your neural network, whether it's for training or testing. So we can use a lot of Torch Vision transforms, which has a lot of different functions and classes built in there that will help you easily deal with this. Now you'll take the time to read the tutorials and the documentation later, but obviously you know that there is a lot of them already available. Now here what we're going to do is we're going to transform all of our training data to the resolution 224 by 224, and we're going to randomly flip them along a horizontal axis. So here we have the class random resize crop, which is going to resize and then crop images so they are of the resolution 224 squared. It's going to horizontally flip them randomly, right? This is a form of data augmentation. We'll learn about that later, but it's just essentially adding, superficially, artificially creating more images by just flipping the images that we have randomly. Then we are converting all of these to tensors, and then we're normalizing them. This is based on the values that we have here. It's trying to create a more balanced data set. This is based on the data that we already have available. So our data is in a more sensible range. For example, there are zero mean unit variance or whatever form of normalization you're going to apply to them. Obviously, we'll have to, let's run this train transform. Let's see what the error is. of course, we didn't actually import the torch and torch vision here, which is an important essential part of this here. So right now we're using torch vision transforms to do this. So we have created the transform. Right now we haven't actually applied the transformations. We're just creating the list of transforms that we're going to apply to our data later. We'll do the same thing to our test data. Well, obviously you have to be careful that whatever transforms you apply to the test data, it has to be as close as possible to the future unseen test data that you will see in the real world, right? So if I have, for example, you can't just randomly rotate your test data if in the real world the images you're going to be receiving are not rotated randomly. So you have to try to sensibly transform the data to be as similar as possible to the real world distribution. Now that we have created the transformations, it's time to create our dataset object. So here we're going to, because we have our own dataset, we're going to use the image folder class from Torch Vision to help us do this. Now note that here we're not actually loading the dataset, we're just creating a data structure that will tell us where the data is. So using Torch Vision datasets in image folder, I'm just passing the train, I'm creating the train dataset by pointing it at the train directory, and the test dataset by pointing it as the test directory. The directory, the path actually where my test data is sitting. And then based on this, I should be able to find out how many images I have in each of these. So once I do this, we'll see that there are 120 images in the training set and 60 images in the test set. So we said that earlier, we have 60 images per character for the training set and 30 images per character in the testing set, which overall gives us 120 for training and 60 for testing. Now here, for example, I can have class names extracted. So if I have this train data set that I've created here, dot classes is just going to give me the name of the classes, and I'm going to list them here using a comma as the separator. And we'll see I have two. I have Admiral Akbar and Jar Jar Binks, the name of my classes. So I have the labels and I have the images that are built in there. Now before we can actually look at the image, we need to technically load the data. So far we haven't loaded anything, right? We've just created structures that are pointing to where the images are. The data loader in Torch Vision, in PyTorch utils actually, it's not in Torch Vision. It's responsible for actually loading the data. Now remember that we're not meant to load the whole data all at once, right? Data sets in deep learning can get very large. And by large, I mean very, very large. We can get into terabytes very easily, especially when you get to industrial commercial applications. So there is no machine that can fit all of that in memory all at once, which is why we're meant to load the data in batches. So which you will hear the word batch a lot in whatever project you're going to be dealing with. So here we're going to be loading the data in batches of 4, and we will shuffle them during training, right? Randomly we'll pick them up and use them to train, but during testing we'll turn off the shuffle flag. We also have something called the number of workers, which is it refers to the number of threads. If in the machine you're using you have cores that support multiprocessing or multi-threading, this can help you actually do a lot of reading and processing of the data and the transformations in parallel, so that things can move along faster as you're processing your data on your GPU hardware. So let's create this train loader and the test loader. As we see, the batch size is 4 for both of them. For our training set, the shuffling is true, and the shuffle flag has been set to false for the test data. And obviously the number of workers for both I have put as 2. Now that we have actually loaded the data, we haven't actually technically loaded the data, we have created the data loader, and now we can actually look at the tensor. So let's turn this into an iterator, and we can print the size of the x and y. So x should be our images, y should be the labels, what they actually are. Now we can see that we have a tensor of size 4. This is our batch size, how many images are in that batch. By 3 is the number of channels we have. The images, you saw samples of those were RGB images, color images, therefore they have 3 channels, and of the resolution 224 by 224, which if you remember we set during the transforms we were creating. And our labels are just in a list of 4, right? We have 4 images in our batch, therefore we have 4 labels. Now let's try to visualize these images. We want to try to look at them. Now obviously you can use a number of packages to visualize images. You can just use OpenCV, Matplotlib, or Wisdom, which we looked at in the earlier part of our series on the setup. We talked about Wisdom a little bit. But here it's a good idea to take a look at weights and biases, which is very much popular. It's a very powerful package, and it's used a lot in industrial settings specifically. Now it is free for individual users, but for companies and corporations it is a paid service. But right now we can visit their website and see how things look. You have to try to log in. I'm going to log in using my let's see what the issue is here. Right, yeah, so I've already logged in using my GitHub account. So we have to install the package on Google Colab. It's not there by default, so we just pip install it, W and B, and hopefully it shouldn't be too long. It's not a very big package, right? And then we'll need to import the module, and we need to log in. Obviously there are credentials, there is an authorization key for every user, so you can access your dashboard and see the projects or whatever you're trying to visualize. It has a lot of capabilities. So here we have to put in the key. Each person has a key, so this is my key. I'm just going to copy this here and then here paste it in, and the key was true and we are connected. Now it has lots of capabilities. It has for model versioning, for tracking your experiments, for visualization, for optimization, hyperparameter tuning. It offers a lot of cool stuff very easily. It gives you a big tool set. Obviously here we're just gonna look at this just as a visualization tool, just as a simple demo. So we're going to initialize a project. We're going to call our project Super Duper Demo. So this will be created in our dashboard, and we can look at that later. So here we're going to load a batch from our training set. We have the column. We're going to make a table of the images. I'm going to call the columns image and label, obviously. And I'm going to iterate through my data and add the image and the class names into my table, and then try to display them there. So here, if we go to our dashboard, so here we have the project Super Duper Demo. As you see, it's been created, and here we have a table called ACBink images, and we have a list of our images, like a table with our image and label. So we have an image of Jar Jar Binks, an image of Admiral Akbar, and 2 other images of Jar Jar Binks from our dataset. So this is it's very, as I said, weights and biases is very easy to work with, and it's very much used in many industries nowadays. So it's a good skill set to have now to be able to use that. Obviously we don't have to use things like weights and biases. We can just use Matplotlib, which I've done here in the next section. And then using Torch Vision has a make grid thing we can use to actually create a grid of our images in our batch and display this very simply. Here we have 4 images again of just using Matplotlib. We have Admiral Akbar and Jar Jar Binks and 2 Admiral Akbars again. So that's it. Now obviously we don't have to always, there are lots of data sets already built into PyTorch. In the real world, obviously you're not using the built-in PyTorch data sets, which is why we started off with the data set that we're going to create our own. But there is a very large list of data sets that Torch Vision already has available for different tasks. for things like classification or more advanced computer vision tasks like image detection, like object detection, segmentation, optical flow, lots of different tasks. So there is a large tool set available. Let's look at how we can use those. For example, the seminal MNIST dataset, which is a handwritten digit recognition dataset. There are sets of numbers from 0 to 9 written by hand, and we're trying to classify them into to identify essentially what character they are referring to. So I can create an MNIST loader, torch.utils.data data loader, and then I have just in the datasets.mnist, and I easily have the MNIST data here. I can set it to download true, meaning it's just going to download it right here in the directory that I have, and apply the transforms. I'm going to resize it to 32 by 32. The original images are 28 by 28. It's obviously easier if it's we have like powers of 2, like 32 here is easier to work with in deep learning, especially when it comes to when you have models, when you have a network that is cutting the size of the image in half or growing the size of the image by factors of 2. You want it to be always divisible by 2, no matter how small you make it. We are shuffling him, and the batch size of 64. Let's just run this. It's going to download the entire MNIST dataset right here, and MNIST has been loaded. Now using matplotlib again, let's just visualize this. So here we have a simple batch. Here the size of our batch is 64. It's a 1-channel image this time. This is just grayscale. And it's 32 by 32 because we made it so when we applied the transforms to it. So it'll be good to have a look at Torch Vision, the sort of transforms it offers, the sort of data sets it offers. It can give you a very interesting, simple tool set to work with to make especially computer vision related projects very easy to handle. Right, that was this for datasets. I hope you have learned something. Thank you very much.